Okay, so let's go ahead and do this polynomial long division on example 12. So my first polynomial that I see there is my dividend. That's going to go into this division sign. My divisor is x plus 5. That goes outside. Okay, so our process is going to be very similar to what we saw with integers. Okay, it's going to be a little bit different just because of the nature of the polynomials, but it's going to be very similar. So the one thing is with polynomials, I'm only going to be looking at the leading coefficient for the first step here. So I want to know, just like before, how many times x can go into x squared, just like I was trying to figure out how many times 3 can go into 28. The other way you can think about it is you can think x times this thing right here has to equal x squared. And it's always going to equal exactly that for this first term. So if you think x times what equals x squared, or you can think x squared divided by x equals what, which would be x, right? So I'm going to put an x there. Now I multiply just like I did there. But I'm going to multiply now by every term in the divisor. So x times x is x squared. Then x times positive 5 is positive 5x. Okay, so just take a minute and see if you understand what we did so far. We figured out x times what equals x squared. Or we can think x squared divided by x. Either way, we need an x here. So I put an x here, and then I multiply by both of those terms here. X times x is x squared, x times 5 is 5x. Now think about what we did next. We subtracted. When we subtract here, we just plop a subtraction sign in front and subtract. Here, it's a little different because I have more than one term. So I need parentheses. Okay. Sometimes people are taught to not put parentheses, just put the opposite signs. I mean, that does the same thing. But I kind of like to do it like this because it really shows what's happening. X squared minus x squared. This first set of terms will always cancel out in polynomial division. Negative 2 minus 5 is going to be negative 7x. So I've subtracted. Now I bring down. And now I start again, just like I did there. And again, at this point, I'm only looking at the leading coefficient. So I'm only looking at the x and the negative 7x to figure out what's going up here. But once I do that, then I multiply this by everything. Okay, x times x is x. Oh, I know, sorry. So then here we go. We have to see how many times x goes into negative 7x. Another way to think about it is negative 7x divided by x. If I think about it that way, I can see that it's going to be negative 7 because those are going to be cleared out. Or I can think x times what multiplies to be negative 7x. Either way, it's going to be negative 7. Now I multiply. Negative 7x minus 35. Put it in parentheses so I can subtract the whole thing. Negative 7 plus 7 cancels out to 0. Again, every time you go to subtract, those first terms are going to cancel out. Negative 35 plus 35 is also 0. Similar to over there, we have a remainder of 0. So the answer is called my quotient for any division problem. So my quotient here is x minus 7. Okay, now when you think about something for a minute, let's say I have 12 and I want to divide it by 4 and I decide that my answer is 3. How could I check that? Well, to check it, I can say, well, 3 times 4 does equal 12. So it's the same idea here. I had x squared minus 2x minus 35. I wanted to divide it by x plus 5. My answer is x minus 7. I can check it by multiplying my answer times the divisor and seeing if I get what I started out with. Okay? If you have a remainder, you just have to add that in at the end to get what you started out with. Okay. Let's do one more. I'm going to skip down to number 14 because there's one thing in there that I want to mention. Okay? And again, don't stress yourself out about these. Hopefully you kind of see where it's going, but don't get yourself too crazy about them. All right, so number 14. And the reason I want to look at number 14 is there's one extra little thing we have to do in here. So, in example 14, we have x cubed minus x squared minus 4 divided by x minus 2. And if we look at this dividend, and we're thinking about the exponents, we kind of see that there's something missing. There's an x to the third, there's an x squared, there's no x. So there's no x term here, okay? We need to have, whatever the biggest exponent is, we need to have a slot for every exponent from there down, in the dividend and the divisor. Now the divisor is okay because we have x to the first and then a number. That's fine. So when we write this dividend in here, we need to have a slot for that x. So what I can do is I can just put plus 0x. If I were missing x squared, I would put plus 0x squared. It doesn't change what I have in my polynomial at all, but it gives me that x spot. The reason is, if you look back at the first one we did, we didn't even think about it, but x squared ended up lined up with x squared, so I could combine those like terms, and x lined up with x, so I could combine those like terms. And if I don't have this, then in the middle of here I'll end up with like an x squared over an x, and I can't combine them, and it'll get a little crazy. So that's why I just need this slot there. It doesn't change what I do from here on though. So again, let's look at this. Leading term, leading term. X times what gives me x to the third? Or x to the third divided by x equals what? Well, it equals x squared, right? If I divide my like expressions with like bases, I subtract the exponents. So here's going to be x squared. Now I multiply this by both terms. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Don't forget now I want to subtract more than one term, so I need to put it in parentheses. This cancels out. Negative x squared plus 2x squared. Negative 1 plus 2 is 1. Okay, so just to think about what's happening there, if it's easier to see it like this, so it's like negative x squared plus 2x squared. Negative 1 plus 2 is 1. I'm going to go ahead and bring down the next thing. Now, I usually actually bring down everything, but for ours, you don't have to. Okay. Leading terms again. X times what is going to be x squared? Well, that's x, right? X times x, positive, so I put a plus there. X times x is x squared. X times negative 2 is negative 2x. Do you see now why I need that 0 there? Otherwise, my negative 4 and my negative 2x would be lined up, and I couldn't combine like terms. These cancel out. 0 minus negative 2 means 0 plus 2 is 2, x minus 4. Okay, final time, leading coefficients, leading terms. X times what is going to be 2x? Well, that's 2. X times 2 is 2x. I multiply 2x minus 4. 2x times minus 2x cancels out. Negative 4 plus 4. Again, we have a remainder of 0, so my quotient is x squared plus x plus 2. Again, if you wanted to check this, you could take this and multiply by x minus 2, using what we did earlier today, and you should end up with what you started with. Okay, so really concentrate on the addition, subtraction, multiplication, and the division with monomials. Please do look over the division with polynomials, the long division. But as I said, you're not going to be tested on that. So you kind of lucked out for that. But I do want you to kind of just be familiar with the process, even if you couldn't exactly replicate it right now, because it will help you when you go over it in Math 120 next semester. All right, so that's it for Chapter 8. And as always, email me if you have any questions. And this week's office hours are on this week's to-do list. All right, thanks, guys.